Hi guys, this is Amin and I'll be doing a presentation on the hydration of norbornylene. So let's get started. What is hydration? Hydration is a process in which a water molecule is added to another molecule. I have a picture here to represent that. I've got an alkene with a hydronium ion showing a hydroxyl group and a hydrogen molecule attached to it, hence a water molecule is added. Nucleophilic substitution reactions. This reaction is key to the experiment that we'll be performing, which is hydration of norbornylene, which is why I discuss it here. What is a nucleophilic substitution reaction? It's a reaction in which an electron-rich molecule is added to a positively charged electrophile, replacing the leaving group that's on there. Got a mechanism here to show you guys. So in step 1, the leaving group leaves, creating a positively charged electrophile, that's the carbon in the middle, allowing the nucleophile, which is an electron-rich molecule, to go ahead and attach to that positively charged carbon, which is an electrophile here, hence replacing the leaving group. Acid catalyzed hydrolysis. That's the specific reaction that we're looking at here, which is acid catalyzed hydrolysis. In this case, in the presence of a protic acid, which is the H3O plus ion, it's used to catalyze and break the bonds of a molecule via adding water to it. Here, I've written hydronium ion acts as a catalyst, and alcohol is add to alkenes, and we'll see that soon. I've got a quick mechanism I drew up here for you guys, in which an acid catalyzed hydration is shown. We've got a pi electrons acting as an electrophile here. The proton there on a hydronium ion is being taken up, creating a positively charged electrophile, which is then attacked by an electron-rich water molecule, which gets attached. Then another water is added to neutralize that water because now it's positively charged. And we know that we need it to be neutral because that's its most stable form, which is then resulting in a hydroxyl group attaching to that alkene, leaving with the hydronium ion as a catalyst. So that's why we get a regeneration of it. The purpose of this experiment, what are we doing? What are we doing here specifically? The purpose here is the hydration reaction of an alkene. We'll see norbornylene acts as an alkene, and we're doing hydration to attach an alcohol onto it. It's in the presence of an acid, the protic acid, and it's a stereospecific addition reaction, which I'll discuss more in further slides, which is key to the reaction we're performing here. Some of the techniques used are sublimation, and another cool rotoevaporator was used here, which was unique to myself, and I'll be discussing it a little bit more. Norbornylene, what is it? Let's talk about the structure a little bit. It's a cyclic hydrocarbon with a cyclohexane ring, right? And then it's got a methyl bridge there and a double bond in this case. It acts, it looks like a white solid in terms of its structure, and it has got a sour odor to it, which is why we worked in the fume hood the whole time, as many of us know. Its chemical formula is C7H10, a molar mass of 9415 grams per mole. It's got a melting point of 40 to 46 Celsius and a boiling point of 96 Celsius. I quickly added the products that we are assumed to or predicted, and we see here that we get 2 products, which can be deceiving. So I'll kind of explain what's happening here. When we perform the hydrolysis on norbornylene, you should expect 2 products, the endo and the exo, which basically means the attachment point at which the hydroxyl group will attach. And you'll see something to bring your attention to is the melting point here. They vary. The melting point of the exo molecule is 124 to 125 Celsius, whereas the melting point for the endo molecule is about 149 to 150 Celsius. This is how we'll distinguish what our product will be through our experiment. Steric hindrance. Steric hindrance plays a huge role in determining where that position goes, so whether it's going to be an endo hydroxyl group attachment or an exo hydroxyl group attachment. So we'll see here, steric hindrance plays a role. So quickly define what steric hindrance is. Steric hindrance refers to the accessibility of other molecules to attach onto that carbon molecule based on the electron clouds present from the neighboring molecules, such as in this example that I provided. I've shown that molecule A has 3 methyl groups attached to it, whereas molecule B only has 3 protons attached to it. We all know these are more bulkier, even though they're not super electron rich, they do play a big role if we wanted to compare. So as predicted, if I was a nucleophile, I would go ahead and attach to the less crowded molecule there, which would be molecule B with the 3 hydrogen molecules, not the methyl groups. I have a mechanism for the acid catalyzed hydration of norbornylene here. So we can clearly see what is happening and how it's taking place. So here we see that we've got a double bond, which is the alkene on norbornylene. It takes a hydrogen molecule and it creates a positively charged carbon molecule, which acts as a positively charged electrophile. The hydronium ion, which is positively charged, is now neutral, becoming a water molecule, which acts as an electron-rich nucleophile. That nucleophile will go ahead and attach onto the electrophile, creating, again, similar idea as to nucleophilic substitution. So same thing we explained, the next steps are quite the same, and we observe 2 different products. We observe both the exo position and the endo position, and just kind of remind the melting points there as well. Acid catalyst. What is a catalyst? A catalyst is something that will increase the speed of a reaction without actually being taken into the experiment. And in this experiment, our catalyst is the hydronium, which is why it plays a role, it plays a really big role in the experiment itself. However, we do see a regeneration of the hydronium ion. So if I quickly go back to our nucleophilic substitution reaction here, we also see a catalyst here, which is the hydronium ion. So this is the acid catalyst reaction. For the experimental part, there were a couple of techniques that were really crucial into performing the experiment itself. One key one was sublimation. What was sublimation? So I want to define it for you. Sublimation is a process in which a transition state occurs. So where a solid molecule will go to a gaseous molecule. There, in this case, we can see we've got an image there. That's what it kind of looks like, because it's really hard to imagine. We don't see it a lot. We see melting a lot. That's another transition state. A lot of snow out there, right? And it was used for the purification of norbornylene. I've also provided an image of the cold finger where we were performing the reaction. For myself, that was quite unique because I've never used a cold finger before. So I've shown a picture there, and basically the cold finger was placed into this long beaker to gather all the crystals from the reaction when we were performing the sublimation as it becomes a gaseous state, basically. So that was quite unique. A roto-evaporator was also used. I'll kind of define what the purpose of a roto-evaporator is. It will separate a solvent from its sample. So this is the best way to do it. It's the most gentle. It was a very unique experience for myself because I've never used one before. So that's one way to do it, and that's what we used in this experiment. Finally, utility. What is hydrolysis used of? So if we go back to the definition of hydrolysis, what did we kind of say? We said that it's used to break down chemical bonds using water. And when you think of that, it kind of sounds like digestion, right? That's the first thing. You break down molecules, break down bigger sugar molecules into primary sugar molecules such as glucose in order to digest material. Another thing I found unique was that production of paper and biofuels from cellulose was also another process that used hydrolysis in this case. So that is all for my introduction. I've provided some references there for you to check out. And I hope you enjoyed the presentation and learned something, and will keep you updated on the discussion section for the hydrolysis of Norbornylene.